Hi, welcome to Vision classes. It's a classes for IGCSE, GCSE, AS and A-level student. So today we have to discuss the drone and related physics concepts. So theory and application structure through the videos and the images that we have to discuss. So firstly we'll have I hope you must have seen the day-to-day life, right? So we have all the concept related to physics applied for the drones as well. So first one, Newton's third law: every action there is an equal and opposite force acting on the object, right? So here you can see in the video as well, the propeller spins, push the air downward, the action of the force by Newton's third law. When air pushes on the propeller with the equal and opposite force, the propeller or the drone moves upward. So equal force and equal reaction. So then nextly, Newton's first law: object remain at a rest or moves at a constant velocity unless and until acted upon by the resultant force. So when drone hovers perfectly still, thrust and weight exactly balance, isn't it? So hovering condition means basically thrust force is equal to the weight acting downward, so resultant force becomes zero, and that's a perfectly balanced. Then Newton's second law: so resultant force equal to mass times acceleration. To climb the drone, the increase is the rotor speed, so thrust exceeds the weight, resultant force now point upward, so it's a accelerating. You can see here as well, so it's a F is equal to ma, fine. So m is equal to, now F thrust minus the weight upon small m, fine. Then next one, the moment and torque cancellation, fine. So moment is basically turning effect of forces. It's there in our IGCSE or AS and A level physics part, right? In the system is in rotation, null equilibrium, so clockwise moment is equal to anti-clockwise moment, isn't it? And diagonally you can see here the rotation of the drone motors takes place. Okay, each spinning propeller create the reaction torque on the drone body. So frame wants to spin the opposite way to the blade, just like a helicopter without a tail rotor, right? So here basically sum of clockwise moment is equal to sum of anti-clockwise moment. So that's how it cancels it out and it moves up and down, right, left. All right, nextly the steering, okay, roll, moves left and right. So unbalanced movement cause the rotation and combined with resultant force, so it produces the both turning effect and the directional motion, fine. So here to move the forward, drone speeds up the rear rower and slows the front one. This tilts the whole frame nose down and redirection part of the thrust vector horizontally. So that's a pitch, fine. The tilting sideway from left or right movement is the roll, fine. And speeding up one diagonally pair of the rotor relative to the other without tilting, so that creates the net torque that spins the drone around its vertical axis, and that's a yaw, right? So steering is basically deliberate unbalancing thrust or torque to the redirection motion. It's simply as simple as that. Then next one is the circular motion in the blades. So object moving in the circle needs the centripetal force directed towards the center. Okay, centripetal force, I hope you must have gone through it. So every point in the spinning propeller blade is constantly changing direction, not a speed, which means that the accelerating towards the center of rotation. All right, then the next electricity concept, that is electric motor or motor effect. So the changing current conductor in the magnetic field experiences the force. That's a Fleming's left hand rule. Fine. So F is equal to BIL. That's also applied in case of drone. Then nextly, very important, the energy transfer. Energy is conserved, you can see. So it is transferred from one store to another, but the total energy remains the constant. So battery stores the chemical energy, this converted into electric energy, fine, and this converting electric to kinetic energy. So kinetic energy means spinning the rotors, all right, and then the drone climbs means energy converted into gravitational potential energy. It's a mgh. All right. So at every stage, some energy is wasted as a heat in the wires or motor or sound. Fine. Then comes the air resistance and the terminal velocity. So as speed increases, air resistance increases, and the terminal velocity is reaches when air resistance equals to its a weight. So giving the zero resultant force. Fine. And that is also we can observe in case of drone. Fine. If drone loses the power mid-flight, so gravity immediately takes its over and it accelerates the downward. Fine. And you can see the four phases here in this case as well. Fine. Then nextly, fluid dynamics. So faster moving fluid exert lower pressure than the slower moving fluid. Bernoulli's principle. It's a A-level physics concept. So each propeller blade is shaped like a small airfoil. So air moving over the curved top surface travel faster and air beneath. Fine. So lower pressure, higher speed, and that's how means it moves quickly in the fluid. All right. Then communication system. So communication system, electromagnetic waves transfer the information without transferring the matter. So radio waves are used in case of drone to control the signal due to long range and ability to penetrate the obstacles. So remote controllers are used to control the drones, right? So that's nothing but the electromagnetic spectrums. Fine. And meanwhile, even the GPS enabled drones receive the positioning signals from the satellites, also via electromagnetic waves. Yeah. And the last one, center of gravity and stability of the drone. The object is stable when vertical line of its center of gravity fall within the base support. Fine. So it must be vertical. If it falls outside, object topple. This is the basic concept that we do have. So well-designed drones keep its center of gravity low, centered, and directed drone above the middle of its forerotor, so that it will be always a stable condition, and vertical line from the center of gravity fall within the base, so that it's always stable. That's it. I hope you enjoyed all this. I think so 10 to 12 basic IGCSE concept. Keep revising, keep enjoying. Thank you.